بسم الله الرحمن الرحيم. Welcome to the third part of this lecture, which is the volume of solids using the cylindrical shell method. In the last lecture, or the last part, we found the volume by rotating about the y-axis. In this part, we are going to find the volume of the solid by obtaining about the x-axis, not the y this time. And we have this example. We need to use the method of cylindrical shells to find the volume of the solid obtained by rotating the region bounded by the given curves above the x-axis. We have two equations, x equal to 1 plus y minus 2 to the power 2 and x equal to 2. As we did before, the first step, let's sketch the graph for these two functions. The first one, which is x equal to 1 plus y minus 2 square, is parabola, or horizontal parabola, you can say, given by this new curve. This is x equal to 1 plus y minus 2 square. And the other one, x equal to 2, is just vertical line. And my enclosed region is given by this shaded area. And we need to rotate about x-axis. About x-axis means we need to write or to sketch typical rectangle horizontal to the x-axis. So my typical rectangle will be horizontal. Again, this is the cylindrical shell method, not disk. Now about x-axis, so my typical rectangle will be parallel to the x-axis. And we will rotate about the x-axis itself. I have my shape will be something like this one. This will be my shell by rotating this region. So the volume in this case is C to D of 2 by y. Now it is 2 by y because we are talking about the x-axis, we are using the y variable multiplied by the length. For the length of this one, to find the length of the rectangle, it is the right curve minus the left curve. Right minus left. The right one is given by this equation, or this line, it is x equal to 2. And the left one is this one. So I can write it as x1 or x2 minus x1 dy, which is equal to 0 to 2. Oh, sorry, that's 0. C to d of 2 by y multiplied by x2 is given by 2 minus x1, which is 1 plus y minus 2 squared. So again, if we rotate it about the x-axis, we are using the y variable. The function must be written in terms of y. Now, C and D are not given. These are not given in the question, so we have to find them. And we know in the intersection point, this is C and this is D. x1 equal to x2. So to find C and D, let's let x1 equal to x2. So x1 equal to x2. This will give just to find the limits of the integration. I have 1 plus y minus 2 square equal to 2. It will give me y minus 2 square is equal to 1, or it is y minus 2 equal to plus or minus 1. So y is equal to 2 plus or minus 1. That will give me 3 upper limits and 1 at the lower limit. So the integration now of the volume will be equal to V, which is 2 pi multiplied by integration of from 1 to 3 y times. We say this is the right minus left. 2 minus 1 minus dy. 2 minus 1 is equal to 1. So this is equal to 2 pi 1, 2, 3 of y times 1 minus, if we open or expand y minus 2 to power 2, I will have minus y squared plus 2y minus 4. Because we have this sign negative, so we change all the sign inside that bracket, which is equal to 2 pi 1 to 3 of y minus y to power 3 plus 2y squared minus 4y dy. We can cancel this y with minus 3. It will be minus 3 there. So the integration will be now 2y. The first one will give me minus 1 over 4y to power 4 plus 2 over 3 y to power 3 minus 2y squared from 1 to 3, which is equal to 2 pi multiplied by. The first one will be minus 81 divided by 4 plus 2 over 3 multiplied by 27 minus 18 minus, now this by 1, I will have minus 1 over 4 plus 2 over 3 minus 2. Then doing the calculation by the calculator to find the exact value for this volume. And the unit will be cubed unit. Another example. Let's find the volume of the solid obtained by rotating the enclosed region of these two curves about the x-axis. Again, we are using the x-axis. So I have x plus y equal to 4, which is a straight line with this one. And x equal to y squared minus 4y plus 4. This is parabola with this function. X equal to y to power 2 minus 4y plus 4. And we need to rotate about the x-axis. Again, x-axis means we have to graph a horizontal rectangle, typical rectangle, and rotate it about the x-axis, so we'll have this shape. So the volume is equal to C to D of 2 pi y multiplied by x1 minus x2. Or I will say the right curve minus the left curve with respect to y. The right one is bigger than the left one, so it is the right curve minus the left curve, which is equal to 2 pi from C to D, and we need to find C and D later. It is y, x1, the right one. This x equal to 4 minus y. We have to write it in terms of y. So it will be 4 minus y minus the left one. Left one is the curve, or the parabola. It is minus y square. Change all the sign, plus 4y minus 4. So it will be 2 pi from C to D. That will be y multiplied by 4 minus 4. I'll cancel each other. And I have minus y plus 4y, so I will get minus 4y square plus 3y dy, which is equal to 2 pi C to D. That will be minus y to power 3 plus 3y square. Now to find the limits C and D. As we did before, x1 equal to x2. Let x1 equal to x2. This will give me x1 was given by 4 minus y equal to y square minus 4y plus 4. This 4 will cancel this one. Minus 4 with minus y will give me minus 3y. So I will have y square. This will give me y square. This will be minus 3. Minus 3y equal to 0. We can take y as a common factor. I will have y minus 3. So either y equal to 0 or y equal to 3. And it is very clear from the figure itself. Y equal to 0 and y equal to 3 there. So the volume is equal to 2 pi times integration from 0 to 3 of my function was minus y to this one. Minus y to power 3 plus 3y squared. Now integrate, I will have minus 1 over 4 y to power 4 plus y to power 3, and from 0 to 3, which is equal 2 pi multiplied by minus 81 divided by 4 plus 27 minus 0, which is equal 2 pi minus 81 over 4 plus 27, which is 108 over 4 is equal to 27 over 4. Or we can write it as 27 pi over 2. I can cancel this 2 with 4. It will be 27 pi over 2 cubed unit. So this is the idea of finding the volume of a solid by rotating about x-axis or y-axis, but using the cylindrical method. So this technique is different from the first one, which is disk and washer.